So now we are going to discuss about single phase full wave controlled rectifier. It is also known as single phase 2 pulse SCR. Single phase 2 pulse SCR. Okay. Next, in the single phase full wave controlled rectifier, there are two configurations. One is center tapped transformer configuration, or it is also known as midpoint tapped transformer configuration, and second one, bridge configuration. Okay, let us first discuss the center tapped transformer configuration, right? So midpoint tapped transformer configuration, the load is, let us consider the purely resistive load. Okay, so the circuit diagram, here we are having the supply voltage Vs, which is connected across the primary winding of the transformer, and the secondary winding of the transformer is a center tapped. It is a center tapped. That's why it is known as a center tapped transformer configuration, right? Here we are using two thyristors T1 and T2, right? And the load is purely resistive. It is connected here. Okay. The turns ratio of the transformer is such that the primary number of turns is N and the secondary number of turns is equal to 2N. Okay. Next, voltage across thyristor T1 is VT1. Voltage across thyristor T2 is VT2, and the voltage across load is V0, right? Current flowing through thyristor T1 is IT1, current flowing through thyristor T2 is IT2, and the load current is I0. Okay, so in the waveforms, yes, we are having the waveform of supply voltage Vs, the current, gate current Ig, V0, I0 and VT1. In the gate current, we are having the gate pulse for thyristor T1, gate pulse for thyristor T2, and again gate pulse for thyristor T1. Okay, so alternatingly, we are applying the gate pulse to thyristor T1, next T2, next again T1, next again T2, right? Why we have applied the gate pulse to the thyristors, right? In alternate way. Okay, we are going to discuss. Okay, now, so here, let us come towards the circuit, right? So here Vs is equal to Vm into sine of omega t, right? So it is a sinusoidal and it is having a 0, omega t is equal to 0 to pi. Vs is positive, pi to 2 pi, Vs is negative. Okay, so here, so when Vs is positive, plus here and minus here, right? So when Vs is positive means plus here and minus here. Okay, so consider this is like a highest potential point, this is the lowest potential point. Highest potential is appearing at the upper terminal of the primary winding, the lowest potential is appearing at the lower terminal of this primary winding. Okay, so if this potential difference is Vs, can we say that the full potential difference Vs will appear across the primary winding of the transformer? Okay, so Vs is appearing across the primary winding of the transformer, right? Next, so here primary winding is having a n number of turns, secondary winding is having a 2n number of turns, that is a double turns. Okay, so as we know, in the case of transformer, if here voltage is Vs and if the secondary winding is having a 2 times number of turns of the primary winding, right? So what is the voltage that will be appearing across the full secondary winding? It is equal to 2 times Vs. Okay, again the secondary winding is center tapped, so can we say that the voltage 2 Vs is divided as, between these two terminals it is Vs, between these two terminals it is Vs, yes or no? So total voltage is Vs plus Vs, that is 2 Vs. Okay, now again, so here can we say that from here to here the potential goes on decreasing, similarly from here to here the potential goes on decreasing, right? So can we say that compared to this point is at lower potential, but compared to this point is at higher potential. Are you getting the point? Yes, from here to here the potential goes on decreasing. So if the potential here is less than that of this point, but the potential at the center midpoint is greater than that of the second point, right? That is the lower point of the lowest point of the second winding. Okay, so this voltage is Vs plus minus, also this voltage plus here minus here, this is also Vs. Okay, now here thyristor T1, thyristor T2 here. Next, so this polarity plus minus is for when Vs is positive. Now can we say that when Vs is positive, this is like a highest potential point, and highest potential is appearing at the anode of thyristor, right? This is like a lowest potential point, and the lowest potential is appearing at the anode of thyristor T2. Okay, so highest potential is appearing at the anode of thyristor T1. Means can we say that thyristor T1 will be in the forward bias mode, and lowest potential is appearing at the anode of thyristor T2. So can we say that thyristor T2 is in reverse bias mode? Okay, so very importantly, when Vs is positive, thyristor T1 is in forward bias mode, thyristor T2 is in reverse bias mode. Similarly, when Vs is negative, Vs negative means minus here, plus here, here it is minus, here it is plus, here it is minus, here it is plus. So it is like minus plus minus plus. Are you getting the point? Okay, so it is like a highest potential point that will be appearing at the anode of thyristor T2, and lowest potential will be appearing at the anode of thyristor T1. Okay, so when Vs is negative, can we say that thyristor T2 forward bias mode, thyristor T1 reverse bias mode? So important to note that when Vs is positive, thyristor T1 forward bias mode, thyristor T2 reverse bias mode. When Vs is negative, thyristor T2 forward bias mode, thyristor T1 reverse bias mode, right? So coming towards the waveform, right? So here when Vs is positive, yes, just now as we have discussed, when Vs is positive, thyristor T1 is in the forward bias mode. So here during the positive values of the Vs, that is from omega t is equal to 0 to pi, we have applied the gate signal to the thyristor T1 only, because T1 is in the forward bias mode, right? Next, during pi to 2 pi, Vs is negative, right? So we have applied the gate signal to the thyristor T2. From 2 pi to 3 pi, Vs is positive. So again we have applied the gate signal to thyristor T1. Okay, so which thyristor is in the forward bias mode, right? Accordingly, we have applied the gate signal to the respective thyristor. Is this clear? Okay, so next. So now suppose omega t, yes, for omega t is equal to 0 to alpha. For omega t is equal to 0 to alpha. Omega t is 0 to alpha means what? Vs positive, thyristor T1 forward bias mode, but whether we have applied the gate signal to thyristor T1? No. So thyristor T1 will be in the forward blocking mode, right? Thyristor T2 during 0 to alpha, thyristor T2 is in reverse blocking mode, right? So can we draw the equivalent circuit? Yes. From omega t is equal to 0 to alpha, yes, we will be having the circuit like this. Thyristor T1 is also in the off state, thyristor T2 is also in the off state, right? So this is a Vs 0 to alpha, Vs is positive, right? So next, this is also Vs N to N, this one is Vs, again here it is plus minus, this is also Vs, resistance, load current I0, load voltage V0, right? Voltage across thyristor VT1, voltage across thyristor T2 VT2, this is IT2, this one is IT1. Are you getting the point? Okay, now in this case, yes, as both the thyristors are in the off state, right? So what is the current in the circuit? Whether the current will flow from source towards the load? No. So what is the I0? Yes, I0 is equal to IT1 is equal to IT2 is equal to 0 ampere, right? Are you getting the point? Okay, next, what is VT1? Yes, can we write the VT1? Yes, or first can we write the V0? V0 is equal to I0 into R, so it is equal to 0 volt. Okay, next, now can I apply KVL to the first loop? Yes, it is plus Vs minus VT1 minus V0, right? Plus Vs minus VT1 minus V0 is equal to 0. Out of this V0 is 0. So can we write VT1 is equal to Vs, VT1 is equal to supply voltage Vs, right? Similarly, can we apply KVL to the second loop? Yes. So it is plus Vs plus V0 plus VT2 is equal to 0, right? So plus Vs plus V0 plus VT2 is equal to 0, right? Out of that V0 is 0. So can we write VT2 is equal to minus Vs, right? Vt2 is equal to minus Vs. So important to note that in the center tapped transformer configuration, when both the thyristors are in the off state, the thyristor which is in the forward bias mode, across that the voltage is plus Vs. The thyristor which is in the reverse bias mode, across that thyristor the voltage will be minus Vs. Are you getting the point? Okay. So here from omega t is equal to 0 to alpha. What is V0? V0 is 0. What is I0? It is a 0. Vt1 is plus Vs, same as that of the supply voltage. Okay. Here we have drawn the waveform of only Vt1, right? We have not drawn the waveform of Vt2. Okay, but we can draw. Okay. Next. So this is for omega t is equal to 0 to alpha. Next, for omega t is equal to, yes, alpha to pi. For omega t is equal to alpha to pi. Yes, for omega t is equal to alpha to pi. What is the change? For alpha to pi, yes, thyristor T1 is turned on, because at omega t is equal to alpha, we have applied the gate signal to the thyristor T1. So thyristor T1 will act as a short circuit. Okay, so T1 is acting as a short circuit. Okay, so now current will be flowing from Vs T1 load and again back to the Vs. Current will be flowing in the upper loop, right? Upper loop. But what is the current in the second lower loop? It will be 0, because thyristor T2 is in the reverse bias mode. Okay, so thyristor T2 will be acting as an open circuit only, right? Now, so here Vt1 is 0, right? Vt1 is equal to 0 volt. Next, can we apply KVL to the, yes, upper loop? It is like plus Vs minus Vt1 minus V0 is equal to 0. Out of this Vt1 is 0. So what is V0? V0 is equal to Vs. Very important. So thyristor T1 is in the on state and V0 is equal to same as that of the supply voltage. V0 is equal to Vs, right? V0 is equal to Vs. Now, what is I0? I0 is equal to V0 by R. So it is equal to Vs by R, right? So definitely I0 will be in phase with the V0, because load is purely resistive, right? What is Vt1? Vt1 is 0, right? Here can we find the Vt2? Yes, out of the two switches, one switch is in the on state, second switch is in the off state, right? So what is the Vt2? Come on, can we apply KVL to the outer loop? Yes, KVL to the outer loop, it is like plus Vs minus Vt1 plus Vt2, right? So it is plus Vs minus Vt1 plus Vt2 is equal to 0, right? Plus Vs minus Vt1 plus Vt2 is equal to 0. Out of that Vt1 is 0. So can we write it as Vt2 is equal to minus 2 Vs. Vt2 is minus 2 Vs, right? So please be careful in the conclusion. Can we say that out of the two thyristors, when one thyristor is in the on state and second one is in the off state, right? The voltage that will appear across the second thyristor is equal to 2 times of the supply voltage, right? Minus 2 Vs. Are you getting the point? Okay. So for omega t is equal to alpha to pi. For omega t is equal to alpha to pi. Yes, V0 is same as that of the supply voltage, right? V0 will be same as that of supply voltage. V0 is same as that of supply voltage. I0 will be Vs by R. So it is the same as in phase with the V0. In phase with the V0. Next, Vt1 is 0, right? Vt1 is 0. So can we say that from alpha to pi, thyristor T1 is in the on state, right? T1 is in the on state. So if this is the waveform for I0, right? Can we say that this is nothing but the waveform for the IT1 also, right? IT1 also. Are you getting the point, right? Because when T1 is in the on state, IT1 is equal to I0, right? So waveform for the IT1 is also same, right? During alpha to pi, same as that of the I0. IT1 is same as that of the I0. Is this clear? Okay. Next, after omega t is equal to pi, what will happen? Yes, that is from pi to pi plus alpha. Let us discuss from pi to pi plus alpha. From pi to pi plus alpha, what about the supply voltage? Positive or negative? Yes, supply voltage is negative, right? So from pi to pi plus alpha, supply voltage is negative. It is from pi to pi plus alpha, right? Supply voltage is negative means the Vs polarity is reversed, right? So Vs is reversed. So Vs reversed means plus minus. So here it is plus, here it is minus, right? So here it is plus minus. Are you getting the point? Okay. So from here to here potential goes on decreasing. Okay. So compared to this point, this is at lowest potential, lower potential. But compared to this is at higher potential. So it is a plus minus Vs, plus minus Vs. Okay. Now from pi to pi plus alpha, from pi to pi plus alpha, supply voltage is negative, right? And we have not applied the gate signal to any of the thyristor. Okay, so let us discuss what will happen. Okay, so here both the thyristors will be in the off state. So whether the current will flow from source towards the load? No. So I0 is equal to IT1 is equal to IT2 is equal to 0 ampere, right? IT1, IT2 and I0 all will be 0, right? All will be 0. Next, so what is the V0? V0 is equal to I0 into R. So V0 is also equal to 0 volt, right? Next, can we find VT1? Can we apply KVL to the upper loop? Yes, it is minus Vs minus VT1 minus V0 is equal to 0. Out of this V0 is 0, right? So what is VT1? VT1 is equal to minus Vs. VT1 is equal to minus Vs. Are you getting the point? VT1 is negative, right? Why? Because thyristor T1 is in the reverse bias mode, right? Next, similarly, can we find VT2? Yes, for VT2, can we apply KVL to the lower loop? It is minus Vs plus V0 plus VT2 is equal to 0, right? Plus minus Vs plus V0 plus VT2 is equal to 0, right? What is V0? V0 is 0. So therefore can we write VT2 is equal to, yes, plus Vs, right? So here VT2 is in forward bias mode. VT2 is in forward bias mode, right? So therefore, thyristor T2 is in forward bias mode. Therefore, voltage across thyristor T2 is positive. Thyristor T1 is in reverse bias mode. That's why the voltage across thyristor T1 is negative. Okay, and both the thyristors are in the off state. Okay, so here from pi to pi plus alpha, from pi to pi plus alpha, V0 is 0, I0 is 0. Yes, what is VT1? VT1 is minus Vs. VT1 is negative and it is having a magnitude supply voltage, same method of the supply voltage, right? So this is for pi to pi plus alpha, right? Next, let us discuss for pi plus alpha to 2 pi. Pi plus alpha to 2 pi. At pi plus alpha, we are applying the gate signal to thyristor T2. Okay, so pi plus alpha to 2 pi. Pi plus alpha to 2 pi. Pi plus alpha to 2 pi. Let us discuss what will happen from pi plus alpha to 2 pi, right? So here at pi plus alpha we are applying the gate signal to thyristor T2, right? So thyristor T2 will turn on. Thyristor T2 will turn on. So what is VT2? VT2 will be 0, right? VT2 will be 0. So here we can write VT2 is equal to 0 volt. Okay. Next, can I apply KVL to the lower loop? It is plus Vs minus VT2 minus V0 is equal to 0. But what is VT2? VT2 is 0. So therefore, can we write V0 is equal to Vs? Yes, V0 is equal to Vs. Right? Next, what is I0? I0 is V0 by R. I0 is equal to V0 by R. So it is equal to Vs by R. So please be careful. Be careful. Here, when T1 is in the on state, at that time the direction of the current is from right to left. Now also when T2 is in the on state, then also the direction of the current flowing through the load, it is again right to left. Means the direction of current flowing through the load, right? As well as the polarity of the voltage across the load, it will remain same, right? That is from when T1 is in the on state as well as when T2 is in the on state. Okay. Next, now can we find VT1 or can we apply KVL to the outer loop? It is like plus Vs minus 0 plus Vt1 is equal to 0, right? So KVL to the outer loop, plus Vs minus Vt2 plus Vt1 is equal to 0. Vt2 is 0, so can we write Vt1 is equal to minus 2 Vs. Is this clear? The voltage across thyristor T1 is 2 times the supply voltage, but it is negative. Why the voltage across thyristor T1 is negative? Because T1 is in the reverse bias mode, and as we know, out of the 2 thyristors, when one thyristor is in the on state, second thyristor is in the off state, right? The thyristor which is in the off state, across that thyristor the voltage appearing will be 2 times the supply voltage, right? And if it is reverse bias mode, then it will be negative voltage. Is this clear? Okay, so this will continue till 2 pi. Okay, so from pi plus alpha to 2 pi, from pi plus alpha to 2 pi, what is V0? V0 is Vs. What is I0? Yes, it is in phase with V0 because load is purely resistive. And what is Vt1? Be careful, Vt1 is 2 times the supply voltage. Means at pi plus alpha, the Vt1 will suddenly increase to the 2 times the supply voltage. 2 times the supply voltage. Is this clear? Okay. And after 2 pi, the same cycle goes on repeating. Right? So this is about the discussion on operation of single phase full wave controlled rectified center tapped transformer configuration with the purely resistive load. Okay, now let us derive the expressions. Okay, or before that, yes, pi plus alpha to 2 pi, which thyristor will be in the on state? It is a T2, right? T2 is in the on state. So during this interval, T2 is in the on state. Again, 2 pi plus alpha to 3 pi, T1 will be in the on state, right? So the conduction will be like this: 0 to alpha, none of the switch will be in the on state. Alpha to pi, T1 conducts. Pi to pi plus alpha, none of the switch conducts. Pi plus alpha to 2 pi, T2 conducts. Okay, so if this is the waveform for I0, right, can we say that yes, whatever the waveform of I0 from alpha to pi, right, it will be same as that of the IT1 waveform also, right? But during pi plus alpha to 2 pi, what is IT1? IT1 will be 0 because T1 conducts only for alpha to pi. So please be careful.